Good morning friends. In my last video, I explained about fire pump room detail, and today video we are going to see about a high-rise building that is also a luxury high-rise building, complete firefighting system that includes sprinkler system, then standpipe system like fire hose cabinet, landing wall, then clean agent system all together in a single video. So let's start the video. So first you can see the overview of the project. So we have the second basement here, then we have the first basement. The first basement we have the fire pump room, then we have the ground floor, and going up we have the first floor, second floor, third floor, fourth, fifth, sixth, and seventh, and finally eighth floor. So here we have the eighth floor, and finally we have the roof. So we will see one by one what is the systems we have. So first starting from fire pump room, which is in the first basement, the supply connection which is going to supply two standpipe system. That is one first standpipe. I mean the first riser is this one. This is the first riser, and here we have the second riser. So in the first riser we have only the landing wall. So you can see this riser is supply only the landing wall from second basement to top of the floor. So all this floor, this is only landing wall. And coming to the second riser, this is a combined system. So combined system, I mean here landing valve is there, here we have zone control valve. So zone control valve means you know that we have the sprinkler system. So we have the sprinkler here, and along with this one it is connected with the fire hose cabinet. So moving further, you can see all the floors same concept. We have the landing wall, we have the sprinkler system, and we have the fire hose cabinet. So from top to bottom we have the same arrangement going. You can see the basement also, landing wall, zone control wall, and sprinkler system and fire hose cabinet. So we are very clear that we have two riser for this system. One riser is supplying to landing wall, and second riser is a combined riser which is supplies to the sprinkler system, landing wall, and fire hose cabinet. And this is the approved drawing, but still there are two very big mistake is there in the project. If you find out the answer, I really appreciate it, and please add your comment in the comment section, so we got to know how many people find out the answer before I tell the answer at the end of the video. Let's see that. And here what you see here is second basement. The second basement, most of the area is car parking area. So along with the car parking area, we have few more rooms are here. For example, this is the mechanical room and server room, CCTV room, and we have the stormwater tank here. So this some type of service room also located in the second basement. So all this detail also you can see here. For example, the detail explanation is given in the first page, cover page, that is second basement. We have the car parking. Mostly we have the car parking. Then MEP service room, as I told you, we have some MEP room also. Then first basement also we have mostly car parking, and also some mechanical room like heat exchanger room, chilled water pump room we have in the first basement. And coming to the ground floor, apartments are there, and some retail shops are there, multi-purpose hall is there, and again some MEP service room also there. For example, LV room, transformer room, medium voltage room, all these things are there in the ground floor. And first floor to 8th floor, all these are the apartments. Only apartments are there in the first floor to 8th floor. And finally in the roof we have the gym and swimming pool. So these are located. This is the overall detail of the project. When coming to the legend, you can see the first item is ABC portable fire extinguisher, which I indicated at this level. So ABC portable fire extinguisher, we will see in the drawing where it is located. So here you can see, here we have the portable fire extinguisher at a mechanical room. This is the mechanical room. In the mechanical room inside we have an ABC fire extinguisher. Similarly, we have given ABC fire extinguisher at a different location. So here we have an ABC fire extinguisher, and here in the lobby we have fire extinguisher. So overall this second basement, different locations we have given the ABC fire extinguisher. And coming to the next one, we have the fire blanket. So fire blanket and wet chemical portable fire extinguisher, 6 liter class K. So these two item normally we are using only for the kitchen. And here you can see this is the overall first floor layout, and this is full of apartments are there. So there are no mechanical room, no service room. And here I will take one apartment. So here you can see I have highlighted the area, the K they have mentioned K and FBL. So if this is the kitchen area, like you see here, this is the kitchen area. So FBL means fire blanket and K means class K fire extinguisher. And the next one is the CO2 portable fire extinguisher. CO2 portable fire extinguisher normally comes in the electrical rooms. For example, here you can see at this point we have the LV room, MV room, transformer room, all this one. This is the HV room, high voltage room. This is the transformer room. So here you can see CO2 extinguisher. So we have given multiple CO2 extinguisher. This will normally comes in the electrical rooms. Then we have four type of sprinkler used for this project. First one is the standard pendant sprinkler. Pendant sprinkler, normally you know that we are using for the ceiling application. Where we have the ceiling, there we will use the pendant sprinkler. And upright sprinkler, mostly we are using for the car parking where we don't have the ceiling. And standard sidewall sprinkler and extended coverage sidewall sprinkler. So these four sprinkler we have used for this project. We will see what is there. So in the basement, you can see this symbol. This is the upright sprinkler because in the car parking we don't have the ceiling. So all these sprinkler, whatever I used here, is the upright sprinkler because there is no ceiling. So moving further, for example, okay, here you can see I have used the pendant sprinkler. So this area we have the ceiling, and coming to the sidewall sprinkler. So here you can see. And the lift pit, so lift pit I have used the sidewall sprinkler, and also at this point also you can see the extended coverage sidewall sprinkler. So this is the car entrance and exit area. So here also we need the sidewall sprinkler. So sidewall sprinkler I have used it in the both sides. So this is the extended coverage sidewall sprinkler. So like this four type of sprinkler we have used in this project. And here you can see overall apartments area. So here we have used completely the pendant sprinkler because we have the ceiling everywhere. For example, if I zoom this area, so we have the living room, dining room. So here I used all the pendant sprinkler. We have the kitchen here, I used the pendant sprinkler. And going up we can see the dressing room. Like here we have the dressing room. So completely this areas dressing room, so we have used the pendant sprinkler only. But coming to the bedroom, we don't have the ceiling. So because of the no ceiling, if we install the upright sprinkler, it will look very ugly. So that is the reason only the sidewall sprinkler we installed here. This will protect the complete area. So they have verified the maximum coverage also. And also maid room we have installed the pendant sprinkler. So overall for the apartment, like you see here, mostly we have used the pendant sprinkler. Only for the bedroom, because of no ceiling, we have used the sidewall sprinkler. And the next important one is the four-way breaching inlet, or you can say a fire department connection. So in our project, we have the fire department connection like you see here. This is the overall project view, like a site plan. You can say site plan. This is the overall site plan. So here you can see the breaching inlet location, like here, the fire engine hot standing. So this is the road. So the road is coming like this. So here they have made the arrangement for the fire engine hard standing, and this should be accessible with some particular distance. So at this level, we have provided the breaching inlet. So you can see here we have provided the four-way breaching inlet at this point. So this is the ground floor. So we have the fire pump room in the first basement. So from here it will go down and it will connect with the fire pump room. I will show you that one also. At this point you can see this is the first basement which is coming from the ground floor, this line, and this line is going further. And at this point, so this is the fire pump room. We have two compartments and the fire pump room. This complete fire pump room detail I explained in the last video. The link I have given in the description. So from the fire pump room, you can see the two distribution line is going. One line is for the separate riser. I told you the riser diagram. One riser is only for the landing wall. So if we have one stair here. So from top to bottom, we have the landing wall at this point, and we have the another line which is going here. So this riser is called as a combined riser. So combined riser means we have the landing wall, we have the firehouse cabinet, sprinkler system. So this all served by this riser, and this riser is only for the landing wall. And this fire department connection which is coming from here, which is connecting with the discharge side. This is the discharge side, so which is connecting at this point. And the next one is the riser nipple and fire water riser. These two we will see together. Okay, for example, here at this point, you can see the riser is coming. So because the first basement we have the fire pump room. From the fire pump room, the riser is coming from here, and from here we have the connection like this. So here we have the zone control wall. So this zone control wall from this connection which is going further like this, and at a distribution like this. So this is this project, the area is very high, so we have proposed the loop system. So loop system means it will be like a rectangular type will be here. For example, if you see this diagram also, this will go like this and it will go like this, and you can find out the, you can see here also it will go like this, and it will be, this is the cross main line. So cross main, it will come like a rectangle line. So this is going further and which is coming down, and you can see here. So from here we have the connection like this, and finally it will go with the connection of the where it started. So it's coming like this and it's going up, and it is connected with this point. So this is like a rectangle, like a loop system. Because the area is very high, we cannot use the tree type of arrangement. So the tree type of arrangement, one common crossman will come from there, two branches will come like this. So one side maximum 8 sprinkler, another side maximum 8 sprinkler only we can provide in the tree type arrangement, and additionally 2 more sprinkler you can provide, like a maximum 10 sprinkler with some additional condition. But in the loop system you can provide plenty of sprinklers. That is the reason we followed here loop system, because of the huge area. And next one, whenever you are taking the branches, for example this is your cross main, and you have taken one branch from here, you are taking one branch from here, you are taking one branch from here. Whenever you are taking the branch from the cross main, you have to provide the riser nipple. RN mean riser nipple. For example this mechanical room, you can see this is the ordinary hazard. So we have one sprinkler and one sprinkler here. So if you go to the schedule as per NFPA 13, so here you can see ordinary hazard. So 1 inch pipe, it can cover maximum 2 sprinkler. 1.25 inch pipe, 32 mm, maximum 3 sprinkler. 1.5 inch 5 sprinkler. Now you can go to the drawing. So here you can see 2 sprinkler. So we have 1 inch pipe. So at this point it is 4 sprinkler. So 4 sprinkler means I have used the 1.5 inch riser nipple. So whenever you are taking the branch, like here also you can see 2 inch riser nipple. So whenever you are taking the branch, you have to provide the riser nipple. The next two item is only the firehouse reel cabinet and zone control wall. Zone control wall, just now I explained you, it was near to the riser, and we will see what is firehouse cabinet at here at this point. Firehouse cabinet has been given in different location. For example, here you can see the first firehouse cabinet. At this point we have the firehouse cabinet, and additionally you can see at a different location. For example, here also we have one. Here also we have one firehouse cabinet, and moving up. And here you can see we have firehouse cabinet. So different location firehouse cabinet based on the coverage area we have distributed. And the last one in the legend is landing wall. So landing wall I explained already. So this is the riser. So riser, the first one riser is for the landing wall, one riser is for the combined system. And we will see now some important rules. For the first rule, what we are going to see is no sprinkler over the tank. So if you see the drawing, so here we have the storm water tank. So the first rule says that no sprinkler over the storm water tank. So we didn't provide any sprinkler here. And moving further, we can see the domestic water tank, I mean the water supply tank. So we didn't provide any sprinkler here. So additionally we have the irrigation tank, we have the swimming pool, some tanks are there. So for all the tanks we don't need the sprinkler. And the important next rule is sprinkler for the lift pit required as per NFPA 13. So this is the lift. So we have provided 2 sidewall sprinkler. The rule is normally if you see the section, so from the bottom 600 mm maximum, within the 600 mm you have to provide one sidewall sprinkler. The pipe will be taken like this, it will go down, and you have provided the sidewall sprinkler. So I have provided the sidewall sprinkler for the lift pit. And the next important thing is the inspector test connection. First we will see what is inspector test connection. So here you can see in the NFPA 13, they have given the inspection test connection details. So preferably from end of the remote branch line, we have to take the connection like this. Here we have to provide the test wall, inspection test wall, and it will be connected to the nearest drain. So in our project, for example, here you see we have one riser here. And from here we have to see the end point of the project. So we have 2 rules. So I have highlighted here. Inspector tests are not required for deluge system as they have open orifice. No NFPA 13 requirement. This is for the factory mutual global requirement. Coming to the wet system, preference to locate the inspector test remotely from the riser. NFPA 13 2007 you can see this reference. NFPA 2016 you can see this reference, and this is what I showed in the recent edition also. They have mentioned this point. And coming to the factory mutual global, they also have the same rule. Note that factory mutual global system require wet system inspector test to be located remotely from the riser. They have given the reference also. So all this standard recommend this should be far away from the riser. So for example, this is your riser point mean. In our project, at this end point, you can see this end point, we have given inspector test connection with the flushing connection. So at this point we have provided the inspection test connection. This must be provided. The next one is flushing connection in the cross main. So if you can see in our drawing, like this is the riser line which is coming from out top, so it is going to connect with this line. And I told you we have the loop system, so it will go down and up. So if we follow the up sign, you can see here we are taking left side. So here we are providing the flushing connection at this point. So similarly, if you move to the left side, we are taking straight away line like this, and here I am going to upside. So that means here I will provide the flushing connection. So similarly, if you go to top side, I'm taking line like this. So here I will provide the flushing connection. So in the cross main, like here also you can see, I'm taking line like this, and from here I'm going down. So here I provided the flushing connection. So for the cross main, I have provided the flushing connection. So the next rule is electrical rooms like MB room, LV room, server room, IT room, telecom room, no sprinkler, clean agent system should be provided. So we have some special requirement. Let's see that. So you can see this electrical room. So the area is here 2000 by 4200. So the total area for this room is, I will tell the answer in meter. So 2 meter into 4.2, it is 8.4 meter square. As per Qatar, if the area, as per Qatar civil defense, if the area exceed more than 5.1 meter square, we have to provide the clean agent system. Similarly, for the UAE, if the area exceed 10 meter square, we have to provide the clean agent system. So in our case, for example, this is the Qatar drawing. So Qatar drawing, the area is more than 5.1 meter square. So this is the first mistake. So more than 5.1 meter square mean, here we have provided the pendant sprinkler. This is not correct. We have to provide the clean agent system for this electrical room. Similarly, you can see this server room 4 into 2.8. So 4 into 2.8 means, for example, 4 into 2.8, it will be 11.2. So again, we have to provide the clean agent system. Sprinkler is not allowed in the server room, it will damage. The next one is the fire pump for this project. So we have used the electric driven fire pump, horizontal split case, electric pump, and diesel pump also horizontal split case, and jockey pump is a vertical type. You know, there are 4 type of fire pump. So in this project we have used the horizontal split case pump, and the capacity is 750 GPM. So both this one 750 GPM and this one jockey pump 25 GPM, and head we have given 180 and jockey pump 10 meter head higher, 10 psi higher 190. So coming to the minimum duration time, so we have one NFPA requirement here. For example, if you go to this one, okay, here you can see for the light hazard, ordinary hazard and extra hazard, 3 different value we have given. So for the ordinary hazard, the water tank duration is 60 to 90 minutes, and the minimum for the light hazard it is the 30 minutes, extra hazard 90 to 120 minutes, water tank duration should be there. So for this Qatar project, we have followed minimum duration time of 60 minutes. Like minimum duration time of 60 minutes. So the pump capacity is 750 GPM. So 750 multiply with 60 minutes, which will give the answer of tank capacity 45,000 gallon. If you convert the 45,000 gallon to meter cube, it will be 170 meter cube. So the firefighting tank has the capacity of 170 meter cube for the project. And now we are going to see some important material which is given for the project. So first, fire pump we already discussed, it is a horizontal split case. Coming to the piping for the project, for the above ground pipes, they have mentioned ERW pipe has to be followed, and the material what they have given is galvanized steel schedule 40 grade B ASTM A53 seamless pipe. So this one we have to follow carbon steel pipeline ASTM A53 is the standard we have to follow. Coming to the underground pipe, so for this Middle East, mostly we are proposing a HTP pipe. So HTP high pressure pipe will come. For example, HTPE, the standard will be ISO. The standard will be ISO 4427. You can say 4427. That is a standard we normally follow this Middle East underground pipeline. Above ground we will use the carbon steel. And we have given the sprinkler. The next important thing for a sprinkler, they have given glass bulb. It is very clearly mentioned glass bulb sprinkler we have to use, because we have other type also fusible limb that is not allowed in this project particularly. So they particularly mentioned glass bulb to use this one. And normally for the NFPA we can use both the type, glass bulb and also a fusible link. Both is allowed as per NFPA. And hose reel, the important thing we have to see is very important. What type of material they have given. It's like a stainless steel 316L they have followed. Here we have 2 important things. We have to verify the hose cabinet is freestanding or recessed. Recessed means it is inside the wall. Freestanding means it is not inside the wall. It is just touching the wall. So if it is a recessed means, normally what happen? MS material, mild steel material will be there for all other side, and front side only stainless steel will come. If it is a freestanding means, we can see from the outside the full cabinet we can see left, right, all the side. So that time for the visual point of view they will provide the stainless steel. All side is stainless steel, left, right, top, bottom and front side fully they will provide the stainless steel, which is very expensive. And coming to the recessed mean, mild steel will be there for other side, only for the front side SS will be there. This is not that much expensive. So this point is very important when you go for any firehouse cabinet material. Then for the breaching inlet, is a four-way breaching inlet. They have given four-way with 65 mm connection. All the four-way, and air release valve we are providing for the riser, and pressure reducing valve material they have given, and drain valve also they have given, branch angle they have given. Coming to the wall till 50 mm they have given branch body. So this type of basic material detail also we have to verify in the project. Like shown here, top of the riser we have provided the 1-inch automatic air vent. This is what indicated in the general detail. Now we are going to see the installation detail for the project, and additionally I will explain some important installation mistake which we normally do in the site. So the first installation detail you can see here. So this is for the upright sprinkler installation. So we have the cross main pipe. From the cross main we have the riser nipple which is taken up, and from here we have the branch pipe. So we have the sprinkler line. So this system, this type of arrangement which we normally do in the basement. For example, the basement we saw that we have the cross main like a loop system. So this line is coming like this, which is connecting with the loop system. So in this loop system, everywhere we are taking the line up, and from here we are installing the upright sprinkler. So this this installation which I shown here will exactly match with this installation what we indicate here. So here in this case you can see the distance between the deflector to the soffit top slab, it should be minimum 1 inch and maximum 300 mm or exactly 305 mm. So this should be followed in the installation. This is the first case. Then coming to the second case, here one important thing is, so like you see here, this is the cross main again, and we have the riser nipple, and in this case I have taken the return bend arrangement like this for the pendant sprinkler. So this is the false ceiling. I have taken the pendant sprinkler. Here the thing is, like if it is the cross main, we have to if you are taking the branch, for example pendant sprinkler from the cross main, then we have to take like a return bend. But in the second case you can see this is the cross main pipe, and we have the riser nipple, and this is the branch line pipe. As indicated here, this is the branch line pipe. So if you are taking the branch from the branch pipe for the pendant sprinkler like this, no need to follow the return bend like this if you are taking from the branch pipe. But if you are taking the branch like pendant sprinkler pipe directly from the cross main pipe like this, then you must provide the return bend like this. And in the next case, already the branch pipe we have taken up. Then when you are taking from branch pipe to individual sprinkler, no need to provide the return bend, because normally the dust particles will be settled in the bottom. If you are taking directly from down for the individual pipeline, the dust particle will block the sprinkler. So that is the reason for the cross main we have to take the return bend like this. For the coming to the branch pipe, you are already taking up. So that time no need separate return bend for each sprinkler. This is the important installation rule. And the second very important problem which normally we can see in the lots of project. For example, let's say I am taking the section here to this point. Let's assume that we have the column, we have the column passing here. So I want to pass the pipeline through this one. So I have taken one section at this point. For example, this is the section diagram. This is the slab, and we have the column here. So this pipe which is coming from left to right, I have to pass. Okay. So what happened here? We have the ceiling, and I have very limited space here. Through this one I have to pass the pipe from left to right. So what normally we do in this case, we normally take the pipe like this, we will go down, we'll pass through like this, and we will take up, we'll pass through like this. So this is one of the important problem we do in the site. So like up and down. So normally what people understand, this firefighting is a pressure line. We have the fire pump, it's a pressure line. So taken down and up, it will not create any issue. But NFPA 13 doesn't allow this one. As per NFPA 13, if you are taking up and down lines, this type of improper installation, you must provide the drain. So that is called as an auxiliary drain. You have to provide auxiliary drain wherever you are doing this type of mistake. So this is not allowed. So the question will come then, how to resolve this one, because we don't have the space. So for this type of thing, what you can do is, let's consider the same thing. You have the slab, you have the column, and you have the ceiling here. So here at this point, I mean this point where it is connecting with the main branch, that is at this point. Okay. So you are taking the line like this. I mean here you have the sprinkler. So that sprinkler is this one. You have the sprinkler here. You are taking the line like this. What you have to do, if you are taking down, then you have to continue the same way till the line. You should not take it up. So if you take it up, again auxiliary drain will have to provide. So instead of that, you can continue straight line and you can connect with the line. So this is normally a very good type of installation. Then coming to the next one, we have sidewall sprinkler installation. So in our project, we have sidewall sprinkler. As I told, if for each bedroom we don't have the ceiling, so there we have provided the sidewall sprinkler in the wall. So coming to the sidewall sprinkler, the rule for this like this, you can see the slab. So from the slab to the center of the deflector, we have to follow minimum 100 mm, maximum 150 mm. So this is for the sidewall sprinkler head. The next one is the air release valve. I showed we install the air release valve in the top of the riser. So we have to provide one 25 mm gate wall, and after that we have to do the air release valve, because if you want to do any maintenance in the air release valve, we can isolate using the gate wall. The next important installation in the firefighting system is the zone control valve. So we have the riser here. We are taking the zone control assembly here. The first one should be the isolation valve to isolate the full system in the this side area. So first, after the this should be the supervisory valve, supervisory isolation valve. Mostly it will be butterfly valve we provide here. After that, we have the water flow switch at this point. Then we have the pressure gauge. Then this system line will go to the sprinkler system. And here we have taken the branch line. Here we have two setup. One is the side glass and the test valve to check the water is flowing through this one. We can verify with the side glass. And in the bottom line, we have the sectional drain valve. So both this point will go to the drain line. And here we have the common drain riser. So each floor, this line will be connecting, and it will go to the down. We can connect with the drainage system, like a flow drain and recorded drainage system can be connected with this line. And additionally, we are providing the check valve here to avoid the water flowing back to the system. We are providing the check valve here. The next installation detail, we can see alarm check valve. So in the alarm check valve come from this side, from the fire pump. So we have the OS and Y are indicating gate valve. After that, we can see the two gauges at the bottom and down to see the pressure difference. And here we will have one main drain valve. And this arrangement, it will go like this. Here we have the retard chamber. And after that, this line will go to the strainer. And from here, it will go to the alarm. We have the alarm bell, so it will go to the alarm side. Once the fire happen, we can see the alarm bell ringing. And this is this line which is going to the sprinkler system. Here mainly we are providing retard chamber, because the reason is if there is any minor leakage in the system, unnecessary alarm should not happen. So if there is any small leakage, the water will go to retard chamber. There will be some amount of water will be collected here. It will avoid the false alarm. But when there is plenty of water going to the system, then surely this water will quickly go to the retard chamber. It will fill quickly, and again it will go to the it will make the alarm. So this is to avoid the false alarm indication in the system. And coming to the breaching inlet, or we will call fire department connection, or we will call CMS connection. So in our project, the same arrangement, we have the fire department connection in the ground floor. From the ground floor, which is going down to the first basement, where we have the fire pump room. And in the breaching inlet connection, we must have one drain connection as indicated here. We must have the drain connection here. And after that, this connection must have one check valve or non-return valve, and they providing isolation valve, gate valve or butterfly valve is not allowed as per NFPA 13 in the breaching inlet connection. And the second important issue normally comes to our mind. We have the check valve, but what is the distance we have to provide? Like from the breaching inlet, can I provide in 200 mm or 1 meter or 3 meter? What is the rule as per NFPA 13? The NFPA 13 explains that the check valve has to be provided as much as near to the breaching inlet. It's not like breaching inlet is here and you are providing 15 meter far away check valve. That is not the correct way of installation. You have to try to provide the check valve near, as much as near to the breaching inlet. The next one, coming to the pipe hanger detail. So we must understand one point very clearly written in the NFPA 13, that is hanger components are size considering that 5 times the weight of water filled pipe plus 115 kg. So actually what happened, in the other cases we will not do this type of special requirement, but only for the firefighting the special requirement is 5 times weight of the water filled pipe. For example, we have the firefighting pipe. When the water is completely filled in the system, let's say that it is 100 kg. So 5 times this weight, for example. Okay, for example, the water filled pipe weight is 100 kg. So we can say 5 times. So into 5, 500 kg. Additionally, plus 115 kg. So 115 kg. So total the hanger support should withstand this much load. That means 615 kg at each location. So this is the special requirement for the NFPA 13. And when it comes to the maximum distance between the hanger, we have to follow this NFPA 13 rule strictly. For example, here it is given in feet per inch, here it is given in meter. For example, the first one, steel pipe except the threaded one, Second one is the threaded pipe and copper tube, CPVC, ductile iron pipe. So all these pipes are allowed to use in firefighting system. Mostly we are using the carbon steel pipe for the above ground application. Let's say that we have one 80 mm pipe. 8 mm pipe, 4.6 meter they have given. That means from one support to another support, the distance must not exceed 4.6 meter for the steel pipe. So this rule we have to comply while providing the supports. And this image you can see a different pipe size and hanger rod. So here I have shown like a hanger rod support. So dia 50 and smaller, hanger rod 10 mm we need. So 65 to 80 it is 12 mm, 100 to 125 16 mm, 150 to 100 it is 20 mm. So this type of hanger rod we have to provide. Additionally we have given the angle bar size also. So different angle bar sizes we have to provide for the firefighting system. This is for the pipe. Additionally, this will give the detail of pipe support through the wall. Sometimes we provide the pipe support from the side of the wall. Like you can see, you have to provide the metal angle like this, and the MS angle has to be provided with 25, 25 and 3 mm. And the discharge pipe with the U clamp is provided here. So this is only for the pipe support through the side of the wall. And the next one is the FM 200 because in this project the client wants to use the FM 200. So we have multiple clean agent system like FM 200, Novak system. So we are using FM 200 for this project. So this is a MB room. MB means medium voltage electrical room. So as per the area requirement, the specialist has recommended to use only one cylinder sufficient for this small room. So the cylinder with the capacity 163 pounds we are using, and only one nozzle can cover this full area as per the requirement. So we are using one nozzle. And coming to the others, like this FM 200 is covered with one enclosure here. And the second thing, like we have some detectors, we have the manual release switch, alarm bell, abort switch, and some basic requirement is given in the FM 200 system for this project. So finally, as I explained in the starting stage of the video, we have one first mistake is like for the all the electrical room like a server room, CCTV room, they have provided the sprinkler which is not allowed since the area is more than 5.1 meter square for the Qatar, which is not allowed. We have to provide the clean agent system. If you go to UAE, it is more than 10 meter square. We have to provide the clean agent system. So both the cases, this is not acceptable. And coming to the second mistake, like you can see here for the fire pump room. So at this point the breaching inlet line comes, which is a 6-inch line, and coming to the fire pump room, you can see this discharge line which is going like this way. So this is the 6-inch pipe going to serve to all the floor levels, which is a combined riser, and this is the individual riser which is the 4-inch pipe. This is serving only the landing wall, but here the mistake is like this line which is coming and which is distributed like this. So here it is 6-inch, here it is 6-inch, and the main distribution line here it is shown like a 4-inch, which is not the correct one, because here it is 6-inch mean this has to be the higher size. So this is shown like a 4-inch, it has to be like a 6-inch only. So this is the second mistake for this project. We will update, we updated this one in the next stage. So I believe some of you already find out the answer before I tell in the end of the video. So if you have done, please add your comment in the comment section. So thank you for watching the video. We will meet again with another interesting video. Thank you.